Hi, guys. We're starting our new chapter today, which is the first part of chapter 4. We actually are taking chapter 4 and splitting it into multiple sections. In our first part of chapter 4, we're going to start, and this whole week is going to be all about learning how to factor. Now, I know that we've probably done factoring before in your previous math classes, but factoring is going to be an essential skill that you need to know, not only for this chapter, but for all of our future chapters in Algebra 2 class, like all the way even through second semester. And so it's really important that we go over factoring, that we refresh your memory on how to correctly factor. And there's actually going to be one new method of factoring that we're going to learn together this week. Now, since factoring is an essential part of this class, and since it's something that you're going to need to know all through first and second semester, if you'd like to, we can make a factoring book so that you can find your factoring notes very easily and so that you won't lose them. And so if you notice on the PowerPoint, it says get 3 papers to make an organizational chart. And so if you have colorful paper around the house, or if you don't have colorful paper, if you just have regular white printer paper, you can use that as well. So go ahead, and if you want to make a factoring book, go grab 3 pieces of paper, and I'm going to show you how to make a factoring book. Make the video a little bit bigger. Okay, so I've grabbed my 3 pieces of paper. I have a blue, a pink, and an orange. And then what you want to do is you want to make the papers be about 1 inch apart. And 1 inch is about one section of your finger. So if you put your finger next to it, you want it to be about the length of one section of your finger. And you want to do that with all 3 papers so that they're equally spaced and nice and lined up. So it looks like that. On the bottom, you can't see it, but you can see on the other side it should have it. Okay. So we've got our 3 papers, 1 inch apart each. And then what you're going to do is you're going to take the bottom and you're going to fold it up. Now you want it to still have 1 inch in between. So my middle paper is blue. I do want to have 2 1-inch sections of the blue paper. So I don't want it to overlap. And then once you do that, you're going to fold it down, make a nice crease. And you get this. So I've got my orange, my pink. I've got 2 sections of blue and then a pink and another orange. You can just put some staples across the top here to hold it in place. Okay, so this will be our factoring book. So go ahead and write factor book on it. And then in this, our first video, we're going to learn about greatest common factor. So you can write that across the first section, whatever color it is. Maybe they're all white. I don't know. That's fine. So greatest common factor. And then along the side, go ahead and write the word all. And I'll explain why we're writing the word all later. If you don't want to make a factor book, just go get a piece of lined paper and write greatest common factor across the top, because that's our first type of factoring. That's the factoring we're learning in this video. Okay, so hopefully we're ready now to learn about greatest common factor. If you're using your factoring book, what you're going to do next is you're going to open this section up. Notice that when I used a Sharpie that it bled through to the other side, so maybe don't use a Sharpie, maybe use a pencil or a pen that does not leak through the paper. Okay, so I'm going to open it up, and what I'm going to do to start with for my first slide, I'm going to write that up here on the orange part, and I'll let you know when to start writing down here on the pink part. Okay, so go ahead and feel free to write this slide on the orange part. All right, greatest common factor, otherwise known as a GCF. So greatest common factor is numbers and variables that each term has in common in a polynomial. So a polynomial is just a really long adding and subtracting problem with a bunch of letters and numbers. And what we're doing when we're factoring is we're taking a really long adding or subtracting problem and we're trying to create a multiplication problem out of it. So we're taking an adding and subtracting problem and we're turning it into something times something else. For greatest common factor, we're going to try to factor out numbers and variables that each term have in common. And the greatest common factor is going to go on the outside and it's going to get multiplied with a polynomial, something with many terms. So here's our first example, and again, you're writing this on the top part of your book up here. So I have 2x to the fourth plus 4x to the third plus 8x squared. This problem has three terms. Terms are separated by adding and subtracting signs. And so what we're going to do is we're going to try to think of numbers and letters that each of these have in common, something that I could potentially divide each of them by. And I like to think of my numbers and my letters separately. So looking at just my numbers, I have a 2, a 4, and an 8. Those are all even numbers. And so I can say that each of these terms has the number 2 in common. Each of these numbers is divisible by 2. So that's going to be part of my GCF. And then for variables, I do notice that they all have an x in common. So that's important. And when you're choosing your variable, you do sometimes you need an exponent on it. And the way that you choose the exponent is you just take the smallest exponent available. So I have an x to the fourth, an x to the third, and an x squared. My smallest exponent would be x squared. And so that will be part of my GCF as well. And so my GCF for this problem is 2x squared. So again, I chose a number that divides evenly into all the numbers. Every number is divisible by 2. And I noticed that they all had an x, so I chose the lowest exponent on the letter x, which was an x squared. Once you've discovered what your GCF is, you're going to write it in front of some parentheses. Okay, so I wrote my 2x squared here. It does need to be part of your answer, so you need to make sure that you are writing down the GCF as part of your answer. Inside the parentheses, you will get a polynomial that is the same length as the original problem. So my original problem had 1, 2, 3 terms. So inside my parentheses, I will also have 3 terms. And notice that I kept the same symbols. I had 2 plus signs, so I kept my 2 plus signs. Now to figure out what you have left over inside the parentheses, you're going to divide each of these terms by the GCF. So if it helps, you can actually write that up here, divided by 2x squared. 2 divided by 2 is 1. When you're dividing variables, you can just subtract the exponents. So I had 4 x's up here. I'm dividing by 2 x's, and that'll leave me with 2 x's, so an x squared. So 2 divided by 2 again is 1, and then x to the fourth divided by x squared is just x squared. Again, that was this 4 minus this 2. That's where this came from. Right here, we can also divide by 2x squared. 4 divided by 2 is 2 for my coefficient. And then 3 minus 2 is x to the first, or just the letter x for my variable. And then finally, I would divide this one. 8 divided by 2 is 4. And since these are both exactly the same, x squared and x squared, I will have no letter x's with my last term. This thing down here, with the parentheses and the GCF written in front of it, that is my final answer. And again, this is being multiplied. The whole point of factoring is to get something times something. So you're creating a multiplication problem. You can check your factoring of GCFs if you want to see if you did it correctly by distributing. Factoring out a GCF is actually kind of like undistributing. And so if you try to distribute the 2x squared back in, hopefully it'll give you the original problem, and that's how you know that you did it correctly. Okay, so this is again factoring out a GCF. This whole slide needs to be either written on your lined paper or written on the top of your factoring book. Next, I'm going to put up some try on your owns. If you're using a factoring book, the try on your owns are going to go on the bottom paper, so below the crease down here. And this is the last thing that we're writing on the bottom of the paper, so you can take up as much space as you want to. If you're not making a factoring book, just write these on your lined paper. Please write out the original problem as well as the final answer. These problems don't require too much work. So go ahead and pause the video, try these 3 problems, and then when you've finished the 3 problems, come on back and I'll talk about the answers. Okay, hopefully you paused and actually did these problems. Let's start with the first one, 24 and 40. Now on this one, these numbers are pretty big, so you have to be very careful and make sure that you actually picked the biggest number that divides evenly into 24 and 40. And sometimes we have to factor a couple times. So the final answer for that one is 8xy, and then in the parentheses is 3x minus 5. Now, sometimes we don't get 8 the first time. Sometimes we get like a 4. If you got a 4, then you would have a 6 here, and you would have a 10 here. And what you would need to do is you would need to look at these numbers and say, oh, wait, 6 and 10, I can factor out another number from there. These are both divisible by 2. And so sometimes we don't always factor out the greatest common factor the first time. And so then we need to like keep factoring and factor out more numbers. So if I factored out another 2, that would times with this 4 out here, and that's where the 8 came from. And when I divide these each by 2, that'll get me down to my 3 and my 5. As far as the variables are concerned, they do both have a letter x, and the smallest exponent is this x with the second term, which is just the letter x. And they do both have a letter y, and they were both just the letter y. So I was able to write an x and a y out here. If one of them has a letter and the other one does not have a letter, then you can't write it on the outside. They both have to be sharing that letter for it to be part of your greatest common factor. All right, let's take a look at the next one. For the next one, my greatest common factor, my GCF, was 2x squared y. And then inside my parentheses, I got a 3y plus 4x. Again, notice my GCF is part of the answer. And then in my parentheses, it's the same length as the original problem. So two terms, same symbol, plus and plus. All right, and then looking at that very last one, my GCF is 3pq, and then I have 4p squared plus 4pq plus q squared. You do have to have something that all three have in common. So, if I look at my final answer and I say, oh, these first two have a 4 in common, that doesn't really mean anything because the last one doesn't have a number 4. So I can't really do anything with that. Same thing with my p's and my q's. The first two have a p, but the last one doesn't. The last two have a Q, but the first one doesn't. And so I know that I'm completely done with this problem. So this is how you factor out a GCF. And that's it for our first video. I am going to teach you one other type of factoring today, but that'll be in a second video.